All right, you're welcome to my channel. All right, viewers. So this is a live section which we are going to be using to continue our discussion. There was a discussion we had at a time when we were discussing indices, how to solve problems on indices, and I remember using exercises in showing us how to handle indices problems. Okay, so and in those exercises we ensured that we looked at the concepts alongside the solution of those exercises. Okay, so and we had done a part 1 of that particular series, and we are continuing that in this video. Of course, we had a short break on this particular series because we needed to attend to some of our students who needed our help in some exercises of the math courses they had in their schools. Okay, so and that took a lot of time from us, so but we are back. All right, so now we are going to continue with this and see how far we are going to go. Okay, let me try to do a double line here, okay, on our board. All right, so let's start. Now this is our unscripted exercises, right? So we are going to be doing exercises of a book. Remember, I said I'm using the new National Mathematics, okay, for senior secondary in Nigeria here. Okay, so the work we are going to be doing, of course, they are the same that you do wherever in all the topics. We started with indices, and then we are continuing with it. I think this is the last exercises on indices. Okay, there's another part which I'm going to yet do another video on, and then after that we will now get into logarithms. So we are trying to attempt to use exercises in teaching the audience. The reason is because we've discovered that you actually gain muscles in learning through solving exercises, no matter the subject. That is why we tend to solve a lot of problems here to help our students. Okay, so let's begin. Now here we have 16 questions. Okay, so there are about 16 of them to deal with, and then the other one is about 10. Okay, sorry, 11. Okay, so now quickly let's run through a review of indices and the rules of indices. Okay, number 1 says that if a is raised to the power of n is multiplied by a to the power of m, that it means that a is that this is equal to a to the power of n plus m. Number 2, says that if I have I think I needed to bring this down. Yes, I think that's okay. All right. So number 2 says if I have okay, let me remove this 2 here and bring it this way. Okay, so number 2 says if it is division, a to the power of n divided by a to the power of m, that it is equal to a raised to the power of n minus m. Okay, number 3. Okay, in number 3, I have that if you are given anything to the power of 0, that it is equal to 1. Number 4, a to the power of 1 is the same thing as a. Then number 5, if I have something like a to a negative power, so once the power is negative, is the same thing as the reciprocal of the positive power. Okay, and then number 6, we have what we call fractional index. If I have n over m, so this is equal to the mth root of a, all raised to the power of n. So the numerator remains as power, while the denominator becomes a root. Number 7. Okay, number 7, if I have something like, look at that, say, let's assume that your numerator is particularly 1. Okay, so this is the same thing as just the mth root of a. Of course, when you raise it to power 1, it will still be the same because of this rule. All right, number 8. If I have something like, let's say, a to the power of n is equal to a to the power of m. Okay, so we said that this is only possible if your n is equal to m, so far as your a is not equal to 1. Okay, so these are the 8 basic rules of indices. Okay, of course, there are other ones. Let me try to give another. Okay, it's actually very important. If you have a times b all raised to the power of n, okay, so we said that this is the same thing as a to the power of n multiplied by b to the power of n. That means the power distributes over multiplication. And then the same thing holds for division. If I have a over b divided, all raised to the power of n, that is equal to a to the power of n all over b to the power of n. Okay. Excuse me. Okay, so meanwhile, there is the last rule, which is just an exception. So I'll use a red, so because you are not allowed to do that a plus b, this is actually in 2 places. A plus b to the power of n is not equal to a to the power of n plus b to the power of n, because by binomial expansion, both of them are not going to be the same. The second one, if it is subtraction, then the same is true. Is also not equal to a to the power of n minus b to the power of n. And you can actually see all of this. For instance, look at this. Let me use this very simple example. Let's take it that you have something like 5 minus 3 to the power of 2. Okay, so you know that 5 minus 3 is equal to 2, so to the power of 2 is equal to 4. So of course you will see that if we decide to expand this like this, assuming we say let it be equal to this, so that's going to be 5 to the power of 2 minus 3 to the power of 2, which is 25 minus 9, and that is 16. And of course, this is not correct. It's supposed to be equal to 4. Okay, so that's why it's important to know that this power on addition and subtraction is not distributive, but it is distributive over the, multiplication and division. Look at the one of multiplication. Assume that you have 5 multiplied by 3 raised to the power of 2. Of course, if we use this approach, that's multiplying this out, that's going to be 15 raised to the power of 2, which is equal to 225. Now you will see that this is going to be the same if you now distribute the power and then multiply. That's this way. So you are going to have 25 multiplied by 9. Of course, 25 times 8 is 200, and then plus the remaining one, that's going to give you 225. So you see, 2 of them gave you the same answer. That's to say that this is equal to this. But in the case of subtraction, they are not equal. Okay, so now this is a brief review of the rules of indices. Okay, so no, depending on what you are given, we should be able to know which of the rules that will be helpful. And then, of course, you can combine more than one rule in solving a particular equation. Okay, so meanwhile, when it comes to exponential equations, which is what we are going to be looking at, this particular rule 8 is very important. Okay, so where there is an equality, the basis of both sides are the same, so we are told that their powers will be the same as well. Okay, so we are going to be now looking for, whenever you are given an equation, you are now looking for a way to make the denominator, the basis to be the same, or the powers to be the same, so that you can equate whatever you have. Permit me to change this to black. Okay, so I think that will be a little bit better. All right, so let's go now. We are now beginning our exercises. All right, number 1 in the exercises says that, remember, we are solving all. Okay, so we are solving, and you know, to solve means to get the value of the unknown. And in all the questions we have here, x is the unknown. So we are solving for x. Okay, so let's go. For number 1, we are given 1 all over 5 raised to the power of 2x minus 3 is equal to 625. All right, what a beautiful equation, and we are to solve this. So what are we going to do? All right, so solution. Okay, so what we are expected to do here, like I said earlier, is to try to see, is it possible to make the two parts of the equation to have the same base. And of course, yes, we can write this to be in base 5, and we can also write this to be in base 5. So let's begin to do that. 1 over 5 in base 5 is 5 to the power of minus 1, and there is an existing power there. You can actually put it this way, your 2x minus 3, and that is equal to 625 in base 5 is 5 raised to the power of 4. Okay, and that is going to be giving us 5. Now remember the rule. Okay, I didn't even state that rule there. Call it number 12. If I have a to the power of n or raised to the power of m, this is equal to a raised to the power of n times m. Okay, so if you remove the bracket, the powers will multiply. So that's exactly what will happen here. Minus 1 will multiply 2x to give us minus 2x, and minus 1 will multiply minus 3 to give us plus 3, and that is equal to 5 to the power of 4. Okay, so let's come over here. So at this point, we can now apply our rule. If a to the power of n is equal to a to the power of m, it implies that n is equal to m. Okay, so by that it means that our minus 2x plus 3 is equal to 4. And we are done. Take our 3 to the other side. That will give us minus 2x is equal to 4 minus 3, and that is 1. Divide both sides by minus 2 so that our x can stay alone. Therefore, we have a value for x, and that is negative 1 over 2. Okay, so and that is a solution to the problem 1. Okay, and so I don't know if that is the best approach you think. Okay, so if there is any other thing you need to do, then you can do that. Let me see your comments in the section, in the comment section. Meanwhile, of course, I know because this is 1 over 5, I can easily take the reciprocal, and if we take the reciprocal, this will become negative. Okay, so that's another way we can do that, assuming this was an exam and we needed time. Okay, question 2. So let's write it out. It says 6 okay, so here we have 6 to the power of x plus 2 equal to 216. All right, this one is very simple. Okay, so what do you do? The same process. Now try to write your right hand side and left hand side to the same base. Now, is it easy or possible to write 216 in base 6? And the answer is yes. I can actually write it as 6 raised to the power of 3. You can check that. That's 6 times 6 times 6. 6 times 6 is 36. So we have 36 multiplied by 6. This is 36. 6 carried 3. And this is 18. 18 plus 3 is 21. So that means 6 to the power of 3 is equal to 216. And that completes our solution, which is going to give the powers to be equal. So which will be x plus 2 is equal to 3. Therefore, our x alone is actually equal to 3 minus 2, because it will come over, and that is equal to 1. Okay, so that is the solution for question 2. Okay, so we can probably try to do question 3 here. Okay, so what's example 3? It says you have 1 over 15 all raised to the power of 3x to be equal to 225. Okay, I think I'm going to allow you to do this. In the comment section, let me know what your solution will be, because of course this is going to be just like the first one we did. 225 can go in base 15. All right, so you can just take the both sides to base 15 and then find the value of x. That's very simple and basic. Okay, so we go to question 4. So question 4 says 4 to the power of 2x all over 4 to the power of 3x is equal to 2. Okay, so this is nice. What are we expected to do? Let's try to do that here. Okay, so the both values in the numerator and denominator are in the same base, so we can quickly take one base. Remember, the second rule says that if you have division, you subtract powers. So we'll have 2x minus 3x is equal to 2. And that's going to give us 4 raised to the power of minus x is equal to 2. Then we can write this 4 in base 2 so that both sides would be in the same base. And that's going to give us 2 raised to the power of 2. And that 2 will multiply the existing minus x. And that's going to give us minus 2x. And which is equal to 2 to the power of 1. Okay? And we are done. Take away the equal bases. And so our minus 2x is equal to 1. Which implies that x alone is equal to minus 1 over 2 if you divide both sides by minus 2. Okay, so and that's the fourth problem here. Okay, so let's look at the fifth. Okay, so for the fifth question, we are asked, okay, to also solve this. And how do we go about that? So just the same principle. Remember, like I will always say, that the essence of everything we are doing here is to bring about that opportunity to repeat, solve problems many times, and get used to it. Okay. Okay, sorry about that. All right, so and then okay, so you see the principle is the same. Try to put everything in the same base. And how do you get that? We can take everything to base 3, and that's going to give us 3 raised to the power of 3 will be 27, and that will all be raised to the power of x plus 2, and which is divided by the second one is 3 raised to the power of 2, and that will all be raised to the power of x plus 1, which is equal to 3 raised to the power of 2x. Okay, so now what are we going to do with that? So we can now try to apply our division rule, which says that since the base, okay, first of all, let's open the brackets. So that's going to be 3 raised to the power of, this 3 will multiply everything here, which is 3x plus 6, divided by, so here is going to be, in this case, 2 will multiply everything here, which is 2x plus 2, and that's equal to 3 to the power of 2x. Okay, so now here, what do we now do? So you join the left hand side using the division rule, which says that pick one of the bases and then subtract the powers. So we'll have 3x plus 6 minus 2x plus 2, and that is equal to 3x raised to the power, 3 raised to the power of 2x. And by that time, we just have that the bases are the same on both sides, so the powers should be. And so if you subtract this, you're going to have, or if you open up the brackets, you have 3x plus 6 minus 2x minus 2 equal to, on the right hand side, we have only 2x. Okay, and then we collect like terms. 3x minus 2x is x, 6 minus 2 is 4. Okay, this x should have actually come over this way, but we can as well take the other one to the other side. So if we take one x to the other side, we'll have that 4 is equal to 2x minus x, and therefore our x alone, because 2x minus x is x, and that is equal to the other side, which is our 4. Okay, so and that is the solution to that problem, which happens to be the fifth. Okay, so that is the solution to the fifth problem. Okay, so let's attempt to do number 5 or number 6. Let's do it on the same line here. Okay, so so that's question 6. And what's that? They said we are giving it, so we are giving 8 to the power of x over 2, and that's equal to, here you have 2 raised to the power of 3 over 8 multiplied by 4 raised to the power of 3 over 4. Okay, close bracket. So what possibly can we do here? Okay, okay, we can choose to take everything to the same base, even though I'm seeing other methods, but then those one may not necessarily give us what we want. Okay, so that's in the shortest possible time. So always use the method that will give you, the best approach. That's fast and beautiful way of doing it. Okay, so let's quickly do that. All right, And so what is that? Take everything to the same base. That's base 2. And that's going to be 2 to the power of 3. And that 3 will multiply our x over 2. And then on the other side, here we have 2 to the power of 3 over 8 multiplying 4 to the power of 3 over 2, which you can now reduce to 2. And then that 2 is raised to the power of 2, which is 4. And then that power 2 will now multiply the existing power there, which is 3 over 4. Okay, so now we will try to simplify what we have. So open this bracket, and that will give you 2 raised to the power of 3 times x is 3x over 2. And that is equal to, in this case, let's still gather what we have on the other one. So which will give us 2 raised to the power of 2 will multiply 3 to give us 6 over 4. Okay. Okay, so what can we do next? Remember that this is here. So here we'll now try to now bring down what we have as 3x over 2. And then on the right hand side, you will now apply that first rule of multiplication by adding your 3 over 8 to 6 over 4. Okay, so let's see, 3 over 8 plus 6 over 4. LCM is 8. 8 into this will give us 3. 4 into this will give us 2 times 6 is 12. So, and that's going to give you 15 over 8. And nothing can actually divide, so we just write it that way, 15 over 8. And that's beautiful. And so from there, we are going to now have the bases are equal, so the powers should be. So we have 3x over 2 as equal to 15 over 8. Okay, so we'll now try to cross multiply to be able to get our x. So if we cross multiply, 3x times 8 is 24x, equal to 2 times 15 is 30. Divide both sides by 24. We'll have 30 all over 24 as our solution, which is the same thing as 5 all over 4. That's if we divide both sides by 6. That's if we divide numerator and denominator by 6. Okay, so and that's for problem 6. Okay, so we will now go over to problem 7. Okay, so which is this way, multiplied by 5 to the power of x plus 1 as equal to 0.04. Okay, so what can we do here? Very simple. It follows the same process. Apply the rules of indices. Take the bases to the same base, and that's all. Okay, so let's quickly look at that. So here we can apply the multiplication rule, which is going to give us 5. Since the bases are the same, you now add the powers. Meanwhile, we can open here, and that's going to give us 2x Okay, my board is trying to show that it's down in power. Okay, so that's going to give us 2x. Then 2 times minus 1 will be minus 2. And then it's multiplying 5 to the power of x plus 1. And which is equal to... Now, let's try to change this into... was that? Okay, sorry about that. Let me remove all these lines. Okay, I can't remove this other one. Let me leave them. Okay, so let's try to change 0.04 into the base, into a fraction. Of course, that's going to give us 4 all over 1. Then you multiply you check the decimal places, and then add that number as your zeros. Okay, so if we reduce that to lowest term, we are going to get 1 over 25. Beautiful. And that can be written in base 5 as well. So we can now join these ones here, which is going to give us 5 to the power of 2x minus 2. Then okay, this is multiplication, so it will be plus plus x plus 1. That's the power of the second one, and that will be equal to 1 over 25. And you know that 25 is the same thing as 5 to the power of 2, so we can write this as 5 raised to the power of minus 2 because of that 1 over the reciprocal. All right, and so since the bases are the same, so automatically the powers will be the same. So here we will have 2x plus x, which is 3x, then minus 2 plus 1, which is minus 1, to be equal to minus 2. And then, of course, we are going to have 3x is equal to minus 2. This minus 1 coming over here will be plus 1. So we'll get 3x is equal to minus 1. And by the time we divide both sides by 3, we will get that x alone will be minus 1 all over 3. And that is the solution of that problem. Okay, so we have this is the number 7, so we have number 8 and the rest. Okay, so I will take now I will write that number 8, and then I will allow you to look at it while I just take a short break. Number 8 is given as okay, there are 2 of it, so, and I'm going to be giving you the 2. Okay, so the first one is you have 5 times x raised to the power of 2 over 3. That power is only on x, as equal to 80. Okay, and then the second one is 3x, 3 raised to the power of x minus 1 multiplied by 2 raised to the power of x minus 1, and is equal to 1. Okay, remember in each case we're actually looking for x. So let me allow you to have a go at it. Let's see what you can do. I'll be back in a while. All right, hello everyone. Okay, so you're welcome back. Remember that we are still on question 8. Okay, so here we are asked to do the two problems I and II. In I, we are told that 5x raised to the power of 2 over 3 is equal to 80. Now, since in this case the power is only on x, so 5 is on its own. So the first thing to do is to try to divide both sides by that 5 and know what we are going to get. Okay, so if we divide x by 5, that's both sides by 5, we are going to have x raised to the power of 2 over 3 all over 80 over 5 is the same thing as 16. Okay, so now what's the next thing? Here we have 2 over 3 as the power, so we can clear that power. How? By raising this to power 3 again, so that when this multiplies this will cancel this. But you know, in maths, whatever you do to this side, you also do it here. So we'll just have x raised to the power of 2 equal to 16 squared. 16 raised to the power of 3. Okay, so now what are we supposed to do? Take the square root of both sides. But there is a way we can actually do that, or two ways we can do that to make our work easy. And what is that way? Now, one is to, of course, we can take that square root, and that will give us x is equal to 16 raised to the power of 3, or raised to the power of 1 over 2, which is the meaning of square root. And what's that going to give us? What it will simply do for us is that, remember, you can interchange this. I can actually write it as 16 raised to the power of 1 over 2 or raised to the power of 3. That's actually what we've been saying. And why did we do that? Because we know the square root of that's 16 to the power of half, which is square root, can actually be gotten easily, which is 4 to the power of 3, which is going to give us 64 as the solution. Okay, so let's look at the second part. Remember, this is I. So let's look at I over here. So here we have 3 raised to the power of x minus 1, and then 2 raised to the same power equal to 1. Okay, so since we know that a raised to the power of n times b raised to the power of n is the same thing as ab all raised to the power of n. Okay, so what that means is that I can actually apply that in that number 2. Very simple. And what do? I will note that that is the same thing as 2 times 3 all raised to the power of x minus 1, and that's equal to 1. And so what is our 2 times 3, which is 6 raised to the power of x minus 1? Change this one to base 6, and that will give you 6 to the base of 0. So which implies that x minus 1 is equal to 0. And then from there we can conclude that x alone is equal to 1. And that's the answer for number 28, I and II. And then I think one of us gave that solution. Okay, So we have a solution to number 8. Okay, so let's try to go to a new page. Okay, so and that is question 9. Okay, 9 here, we have 2 to the power of x multiplied by 4 to power x multiplied by 3 to the power of 3x, and everything is equal to 216. Okay, so what do we do to this kind of problem? Right, so this is also going to make use of the rules. So first, we will try to remember, okay, I can take this to base 2 since this is already in base 2, and that's going to give me 2 to the power of x multiplied by 2 raised to the power of 2. That will multiply this x to give us 2x, and that is times 3 raised to the power of 3x equal to 216. However, you can clearly see that okay, so since these two bases are multiplying and they are the same, so this can now be 2 raised to the power of x plus 2x, which is equal to 3x times 3 raised to the power of 3x, all equal to 216. So you can see I'm carrying my 216. The reason is because at this point, I clearly do not know what to raise it to. So I'll keep going until I get a common base here. So, and that is going to be, so here, remember that like what we did in the previous example, we can bring the both of them into the same base, and that, sorry, into the same power. That will give us 2 times 3, all raised to the power of 3x, and then of course this is 6, so I can now write this as 6 raised to the power of 3. Of course, you can remove your equal bases, and that will give your 3x to be equal to 3, and that is my x is equal to 1. Okay, so that's very beautiful. Okay, so let's go to the next one, which is 10. So whenever you are given an exponential equation and you're seeing that you know, the bases are not the same but the powers are the same, so it is expected that you should apply that rule where you can factorize the power, where a power n, b power n is equal to ab power n. Okay, so once you do that factorization, it can now allow you, so this is going to be 4 times 3 all raised to power x to be equal to 1728, and so this is going to give us 12 to the power of x is equal to 1728. Okay, but instead of writing that 1728, so we will try to see, is it possible to write 1728 in index form where the base will be 12? So let's check that. So all you need to do is just be multiplying 12 by 12 and see if you are going to get 1728. Okay, so 12 times 12, 124 times 12 again. So it's giving us 1728. So we only have 12 to the power of 3, and you are done. So our x is now equal to 3. Okay, so recall that, like I said in the first example, that for each of these cases or problems that we have, you can always give a solution in the way that you think best. Okay, so someone actually gave us the answer for 8ii as 1, and which is exactly what we got. Okay, so that's beautiful. All right. So now let's look at this number 11. So this is number 11. It follows the same exact approach I just said earlier on. You can see here 2 has the same power, and then all equal to 1. So you're simply going to just extract the power first. So you have 20 times 5 all raised to the power of x minus 1. Then multiplied by, here we have 8 times 125 all raised to the power of x all equal to 1. Okay, so from here, this is the same thing as 100 to the power of x plus 1 times this one is 1000 to the power of x all equal to 1. But then of course we can rewrite our 100 as 10 raised to the power of 2. So it will be 2 times the whole of this. And we can also rewrite our 1000 as 10 to the power of 3. And so that 3 will multiply x. And you are done. So what do? Just take this one to base 1 also. Sorry, to base 10. And that will be 10 to the power of 0. Okay, so in other words, if we add this, we are going to get 10 raised to the power of, this will be 2x minus 2, then plus, because of this multiplication. And so this one will be plus 3x, and that's equal to 10 to the power of 0. Okay, so that means our, of course, 2x plus x is 5x, minus 2 is equal to 0. So which will give us 5x is equal to 2, and therefore our x alone is 2 over 5. Okay, so that's the solution to that exercise 11. So we go over to 12. So the 12 says that we have 4 to the power of x minus 1 multiplied by 5 to the power of 2x minus 2 all equal to 100. Okay, so I'm thinking I'm going to allow us to do this ourselves. Obviously it looks like the previous one, number 11. Is that okay? Should I? All right, let's do it together. Okay. Okay, so let's try to do that. Okay, first of all, you can see that the powers here are not the same. So, and the bases are not the same. So, you can't even factorize any, and you cannot apply any rule yet. So, but it is easy to change the power of the second one to actually become like the first. Are you seeing what I'm writing? So, you can clearly see that this is the same thing as 2 into x minus 1, because of course if you open this bracket you get back this, and then that has taken us a little bit far, so which is going to give us 4 times 5 raised to power 2, which is 25, and then you bring out x minus 1 as power, and that's equal to 100. This makes your work very beautiful. So of course 4 times 25 is 100 minus this equal to, remember this is 100 all power 1, and so you are done. X minus 1 is equal to 1, and our x alone is equal to 1 plus 1, which is equal to 2. Oh, this is amazing. All right, number 13. Okay. All right, so this one looks beautiful too. All right, 2 to the power of x plus 6 times 5 to the power of 3x plus 4, blah blah blah, and all of that. So what do we do? Okay, so just as we saw in the previous exercise, the bases were not the same, the powers were not the same. All right, the same is applying here, but in that case you could simplify the powers to become the same, but here there is practically nothing you can do. Okay, so what do? You will try to see if you can simplify the bases to become the same. So here I can actually split 10. Watch what we are going to be having. I already have 2 to the power of x plus 6, so leave it that way. Multiplied by, I already have 5 to the power of 3x plus 4, leave it that way. But here I can see that I can split 10 into 2 and 5. So that will be 2 times 5, all raised to the power of x. Okay, so which is going to give me, if you open this now, you are going to get to the power of x and then 5 to the power of x. And this is what I want to use to replace this. So that's the same thing as 2 to the power of x times 5 to the power of x. And the same thing will happen here. I can reduce this to base 2. And that will give me 2 to the power of 2. And that 2 will multiply the existing power, which will give me 2x minus 2, all equal to 1. Beautiful. Okay, so what's the next? We'll now try to simplify. So gather all the ones in base 2, and that's going to be 2 to the power of x plus 6, plus this one, which is x, since it's product, plus this one, which is 2x minus 2. Okay, so I've gathered all the numbers in base 2, so I'll go for base 5, which is going to give me 3x plus 4, then plus this one, which is x. There is no other base 5, so come here and have your 1. Okay, so simplify your powers and see what it's going to look like. So this is going to give me 2x plus x is 2x plus 2x is 4x. Then 6 minus 2 is 4. Multiplied by 5 raised to the power of, this is also 4x plus 4. Wow, this is beautiful. Okay, and then you are done. So you can now bring out the powers, and so this is going to give you 2 times 5, which is 10 raised to the power of 4x plus 4. So let's remove this one. Okay. And okay, so you can see I am now jumping things because you have been doing the same process. So by now you have gotten used to a lot of things. You get? Okay, so of course here I can shift this to this place. And then I can share this into 2. So you see now our 1, okay, sorry, our 1 is 10 to the power of 0. And so that is going to give us of course, equal bases will go, so you have 4x plus 4 equal to 0. Take 4 to the other side, you will get 4x is equal to minus 4. Divide both sides by 4, you will get that x alone is equal to minus 1. Okay? Wow. So that's beautiful. Alright, I'm going to be giving a second exercise added to the first one I gave, and which is question 13. Alright, it looks very simple, so but you have to also tactically look at it. Now, 9 to the power of x multiplied by 16 to the power of x, all equal to 12. Okay, so what is that going to be in your own thoughts? What's that going to be? Of course, this is very simple. So let me see your solution in the comment section, okay? Try to give an idea of what you have. Okay, so let's go to question 14. Okay, it seems I have repeated a particular number. Okay, so this is actually 14, and the one I'm about doing is 15. Okay. So this is 14. And this is 15. Alright, so look at 15. It says that we have 3 all over 4 raised to the power of 2x multiplied by 2 over 3 raised to the power of 2x is equal to 8. I also want to leave this as exercise. Kindly look at it. I think you're going to have 1 over 2 all raised to the power of 2x equal to 8, which will give you minus 2x is equal to 3. Okay, just do that and let me see what you've got in the comment section also. Okay, yeah, just do it. Let me leave it. So finally, for question 16, which is the last example, we are given 2 over 3 all to the power of 3x over 2, then multiplied by okay, permit me to shift this a bit, and then this is equal to okay, we have to still go back. Okay, so the right hand side is like this: 1 all over 8 raised to the power of minus 2x minus 1. Okay, I think I've solved this particular problem somewhere. All right, so let's look at it. So what do you do? Just look at what you've got here. So that's going to be 2 over 3. You can see the other power is a mixed fraction. So let's try to change it first into a normal fraction. Okay, 1 over 6 all raised to the power of, this is going to be minus 3 over 2x, which is the same thing as minus 3x over 2. Now this one, the denominator is to the power of a negative value, so you can now remove that 1 over and change it to positive power, so which is 2x minus 1. Okay, right? So that 1 over removes this negative power, and so this is going to be equal to, so here what do we have? Now we will try to see how to make this to have the same powers. Of course, you can also do addition assuming the bases were the same, but they are not. So we try to make this to be the same power. And how do we get that? Very easy. So we have 3x over 2 times. Now watch what will happen. Remember that when you had x raised to the power of minus n, that is the same thing as the reciprocal of x to the power of positive n. So if I take the reciprocal of this, that's this one now, what will happen is that the power will change to positive, and the reciprocal of 1 over 6 is actually 6. So if I turn this upside down, the power will just change to positive. That's minus minus. It will become minus minus this, which will now be positive, and that will give me 3x over 2, which is exactly what I have here. Okay, so and that will give you 2x minus 1. So in that case here, we are going to have, oh sorry, let's use this. So we can now factorize. So in factorizing, we are going to have 2 over 3 multiplying 6, and then all raised to the power of 2x over 2 equal to 8 raised to the power of 2x minus 1. Okay, so this will take away this to give us 2 here, and when it gives us that 2, so we've got, of course, 2 times 2 is 2 raised to the power 2. Remember, everything to the power of 3x over 2, and that's equal to, can we change this one to base 2? That will give us 2 to the power of 3 into 2x minus 1. And then, of course, this guy here, we cancel this because that's multiplication. So we just have 2 to the power of 3x is equal to 2 to the power of, here will be 6x minus 3, and then immediately equal basis we go, so we just have 3x equal to 6x minus 3. Collect like terms, let this come over here, that will be 3x minus 6x, which is equal to minus 3x minus 3. Divide both sides by minus 3, we'll have that x is equal to 1 as the solution to that problem. And you can plug it in here and see if you will get the same solution. Okay, plug it in here and see if these both sides are going to be equal. Of course they will be. Okay, so that is the last exercise in this marathon problem solving on indices. Okay, so now recall that you can always reach out to us with any question of your choice that you have, and then we can use a video to respond to it. Please do give a thumbs up to this video, subscribe to our YouTube channel if you've not done that, and also share these videos to your friends so that they can also be part of what you are seeing in this channel. All right, and I also have a second channel. All right, that's Maths Experience. That's actually the first one. Okay, so you can go there to see beautiful concepts, a lot of video lessons in maths. They are already there. So that's Maths Experience. Okay, that's my first channel. Okay, that's Maths This Way, then Experience. Okay, so you can check it out and then also subscribe to our channel there. We will see you in our other videos. Bye.